Okay, so we're back finishing problem 5. Okay, one plane started at 520 feet. Okay, that's my beginning value. That's going to be right here. Okay, now once we find the rate, we're also going to use that to figure out what our variables even are at this time, okay? So it says at a rate of 40 feet per minute. The word per is right here circled, and what's the closest number? The 40. So that is my slope, or my m, or my rate, whatever you want to refer to that as. So we have y equals 40x plus 520. We did already say ascending means positive, so the 40 is going to be positive. But what does x and y mean? Okay, whenever you have the word per each and every, it's like getting a gold mine in your word problem, okay? Because there's all this information locked right here that you can pull out pretty easily, and it kind of explains your whole problem to you. Feet per minute can be written as a word fraction, feet over minutes. If you remember how we explained dependent and independent quantities using Dixie and Roy D, Dixie's the independent variable, the cow that goes left and right. Sorry about the glare there. That's on the bottom of my word fraction. That's this one, the minutes. Roy D is my dependent quantity. It's the one that goes on top of my slope word fraction, okay? So when I say feet per minute, I'm saying Roy D is standing on top of Dixie, like we said at the beginning of the year. Feet per minute, that is my y, my change in y over my change in x. Feet is my dependent, and minutes is my independent. So now we understand even what the problem's talking about. 40 times the number of minutes the plane's gone plus the starting value of where it was is going to give me how many feet it is in the air. Let's do the second equation the same way. The second plane started at 3,800 feet or 3,800 feet. It's going to be my B number for that one, 3,800. But this one's descending at a rate of 120 feet per minute. That 120 is a negative rate because it's going in a downward direction. So negative 120x plus my starting value. Those are the two equations. We both have where each plane started. This one's ascending at 40 feet per minute. This one's descending, or negative 120 feet per minute. X is minutes, y is feet. What are they asking? How long will it take the two planes to be at the same altitude? So when we solve, we're going to get two answers. The x number is going to be our minutes. The y number is going to be our feet. They are in the air. Which one do they want? They're asking how long will it take? That's time. So once we solve it, we want minutes. We want this value. Okay, for the sake of time, I'm going to solve it right here. I'm using x and y, so I'll keep it the same. And I put in each equation, 40x plus 520. Y equals 40x plus 520. Arrow down. Y equals negative 120x plus 3,800. There you go. You get a weird number, but this is the answer. The x value, the time, is 41 over 2. We don't usually refer to time as a fraction like that. So how can you change that? Well, just go ahead and put in 41 divided by 2. It doesn't want to change it for you, but you can make it change it by pushing Control Enter. It's 20.5 minutes or 20 and a half minutes. Okay, last couple. And these are easy. Okay, now, if you had to solve this by either graphing, substitution, or elimination, how would you know which way is best depending on how, depending on how the problem's set up, which way would be best. Quick reminder, if they're both in slope-intercept form, y equals mx plus b, that's a good candidate for just graphing them and finding the intersection, okay? If for substitution, ideally you want at least one of the variables to be by itself. At least one. If it is, that's a good candidate for substitution. For elimination, if you added straight down and made columns and added the equation straight down, would you easily cancel one of your variables, one of your variable terms? If you can, that'd be elimination. Okay? So we're going to do the odds, 7 and 9. Let's take a look at this. Well, these are not both in slope-intercept form. One is not. Okay, so, but it's probably not a good candidate for graphing, at least right off the bat it's not. But the y is by itself. So this might be a very good candidate for substitution. You could easily substitute this in right here, solve for the other variable. Okay, so that would be the easiest, most straightforward way out of these three ways. And number 9, well, you don't have either one in slope-intercept form, so graphing isn't good. You don't have any variables by themselves, none of them. So substitution is not good. What about if you added straight down? This is a very close candidate to canceling if we were able to multiply the entire equation by negative and switch the sign. That'd be pretty easy to do. And then add straight down, we could get the y's to cancel. So this is a good candidate for elimination. Okay? Now you guys have had enough practice of actually solving for these and getting the answer in several ways, including in the calculator. So I'll leave that part up to you guys. Okay, so there's your homework tutorial videos for 4-4 practice.